All right, now it's time for a short introduction to these funny new compounds in this chapter. We have alkenes, alkynes, and aromatic compounds a little bit later, but we'll start with the first two. And we kind of recognize that things like this are going to be saturated and unsaturated, and sometimes there's things that are labeled trans, and what does that have to do with our understanding of their names and compounds and structures and so forth. And so here are product labels. One is from olive oil, and it, you can tell, has a certain amount of fat and saturated fat and trans fat and unsaturated and monounsaturated, polyunsaturated. We'll talk about fats much later in the course. And this other one is obviously butter, and it has saturated fat too. Well, surprise, butter has fat in it. And if you want another example of where we do funny things about chemistry, well, you know any organic chemistry jokes? Alkynes! Oh dear, chemists have bad jokes, sorry. And whoa, wait a minute here. Does anybody know who this is? Perhaps you do. This is Caitlyn Jenner and Bruce Jenner. Bruce Jenner was a famous Olympic athlete. I believe it was a decathlon for which Bruce Jenner was very accomplished in the Olympics. Well, Bruce Jenner is now Caitlyn Jenner. So what's the difference between the two? I think maybe you might have heard about this, but this is the trans version of Bruce Jenner. Bruce Jenner in his cisgender identity would be that one, and trans is the other one. Okay, 21st century folks know these things. So we're going to be talking about those things in the context of alkanes and alkenes and things too. So here's another one. Alkenes, my apologies. This is Neufchâtel, except I can't pronounce it. It's the less low-fat cream cheese, and it has fats in it too, saturated fats and trans fats, things to notice that we'll discuss in more detail later. But what does that have to do with alkenes? So, I'll tell these things to stop, sorry. Make that quit. Oh, sorry. Okay, come back. So these are from the beginning portions of the chapter, and don't forget that there are learning outcomes posted in the course documents in the Exam 1 folder. And I'm going to be talking in this recording about these first two portions that otherwise you'd be reading from the chapter, and an introduction to what they're about with the names. All right, the learning objectives from the textbook look like we need to know about identifying the functional groups in alkenes and alkynes, and to figure out the difference between saturated and unsaturated molecules, and then the names of simple alkenes and alkynes, and looking at their structures, and how you get the structure from the name and vice versa. Simple enough. And when the last part of that, but later, we'll talk about in another recording. All right, so my learning objectives that I post on Blackboard for you include these things, and the first two in this portion here is what we'll kind of be working on in the start of the chapter. The other parts come later. So, alkenes and alkynes. These are different from the alkanes. The alkanes were saturated. They can't saturate it in the sense that they can't have more hydrogens on the carbons. So alkanes are that type. Unsaturated compounds could have more hydrogens on their carbons. In other words, they're not as full of hydrogen as they could be. So these are hydrocarbons that have at least one double bond. And so alkenes are category number 1. That is an unsaturated compound, as in this one right here. And this one is got a triple bond. Well, that is also unsaturated because it could contain more hydrogens. And the third one here, well, the middle one then is the alkyne. This is the alkene. And the last one here we'll get to later in the chapter is an aromatic compound with the alternating multiple bonds in a 6-carbon ring. So that's what saturated and unsaturated are about. 2 new terms, but not real complex. Just kind of think about them when hopefully that makes some sense. Surprised, you still need to know your functional groups. Now, once we've kind of recalled what the alkene and functional group is about, we need to know how to name them. And so similar to the strategies that were used for naming alkanes, step 1 is going to sound the same. We're naming the parent compound by finding the longest continuous chain of carbons, but now with one more feature, it has to have the double bond in that longest chain. There are occasions when you'll find an example that makes you think more than once about which way is the preferred longest chain, but it has to include the double bond if it's an alkene compound named. And then you're going to give it the root name, in other words, that describes the number of carbons, but we'll change the ending from the ANEs of alkanes to ENE, or if you happen to have a triple bond, and we won't run into many of them, you'll put the YNE for the triple bond as the suffix. We'll look at them in a minute. Step 2, you're going to number the carbons in the main chain, that longest chain that you've just determined, and you want to do the same as things we've done before. We're going to look for the lowest possible numbers, but they're going to be specifically for the first carbon of the double bond. Or you begin numbering nearest a branch so that other things get lower numbers. Sometimes your double bond or triple bond is in the middle, and you get to choose which end is going to give you lowest overall numbers. All right, so this example at the bottom of the screen is a starting point. And you can kind of tell there's some numbers missing, but let's play with it anyway. So we're going to number 1, 2, 3, 4, 5, 6. So it's going to be hex. And now we're going to change the ending, ene. And we have to use numbers to describe where the first carbon of the double bond is. So are we going to number from the left, or, wait a minute, is there a better choice? So let's try another set of numbers and see what we think. Can you start from here and get a better choice? Yep. So if you go from the right, then the first number in the compound is going to describe the first carbon of the double bond, which will be 2. So this is properly described as 2-hexene, properly named. All right, so there's the longest chain and numbering, describing where the first carbon of the double bond is, our starting points here. There will be other things that you have to find on occasion. This was our 2-hexene. And if you have other substituents, you're going to have to identify them, give them numbers, and guess what? Again, we're going to do alphabetical order for the branches that are off the main chain. You'll use commas between the numbers, hyphens between words and numbers, the same as has been seen before. Once in a while, you'll run into an example that has more than one multiple bond, so those will be called dienes and trienes, and we won't see them very often. But know that they're out there. They kind of make sense. The numbers suggest the positions of those multiple bonds. But don't worry, I don't think I've ever used one on a test. Just be aware that you might run into one and you'll be able to interpret it, I think. All right, so here's a set of examples that give us something to try. And the idea here is to look for the longest continuous carbon chains and see where the numbers should start and what kind of names are going to work with these. All right, start from the top left, because we can. And that looks to me like 5 carbons in the longest chain. Do you want to start here or here for carbon number 1? Well, it looks to me like the lowest number for the carbon of the double bond means we'll number starting here. So that would be 2, 3, 4, 5. And so it's a 5-carbon alkene. It's pentene. The first carbon of the double bond has to be specified, so we'll use that one as 1-pentene. The one below it is one of the few examples with a triple bond present. And so if you can count your carbons, 1, 2, 3, 4, 5, 6. So do you want to start numbering on the right or start numbering on the left? It's 6 carbons, so that would be hexyne. And again, we'll want to start numbering here. So 1, 2, 3, etc. And this time, to give it an explicit name to describe where the multiple bond begins, is on carbon 2. The next compound below that is a good example of how we have to determine where the longest continuous carbon chain is. The shaded box shows you where you need to use, which way you have to go for the longest chain, because if you chose to go this way, I see 7 carbons, right? But we can't go that way because it doesn't include the double bond. We wouldn't not know how to name the fragment with the double bond. We don't have a substituent name that's commonly used for that. So instead, I'll take that and just plain erase it because we're not going to use it. That would not be the way to go. See, come on, eraser. It's a little slow. All right. So instead, we'll use the numbering that's shown with the shaded box. And that looks like 1, 2, 3, 4, 5, 6 carbons. So it's again, it's a hexene because it's a double bond, right? And now we have to decide, are we going to put carbon 1 on this end or the other end? And again, it looks like it should be on the right for carbon 1, but the double bond now begins at carbon number 2, and 3, 4, 5 goes here. But we need to put in another description to describe or explain the other portion of the molecule. So that is a 3 carbon branch, and I'm going to write sideways because I didn't leave very much room. So that is located on carbon number 3. And so 3, but what's the 3 carbon branch? A normal 3 carbon branch like this is just propyl. 3 propyl, 2 hexene describes that structure. All right, here's another one, top right. Keep going, more examples are good, right? So we're going to go, longest chain looks like it's this direction, and 1, 2, 3, 4, 5, 6. Where do we want to start numbering? Well, the carbons of the double bond are exactly in the middle. In this case, we'll pick to start over here with 1, 2, 3, 4, so that the branch is on carbon 2. And so it's going to be 2-methyl. And the longest chain is 6, so it's a hexene. And we put a number of the first carbon of the double bond in the name, so it's 3-hexene. Hope that makes sense. Now, last one. We have, again, a long structure. We have to decide where we want to put the numbers. We're going to have to start on the left because otherwise the multiple bond would get a much higher number. So 2, 3, 4, 5, 6, 7, 8. Wow, 8. So what is that? Oct, triple bond, tyne. The triple bond begins at carbon number 2, so that goes the next thing in front of octyne. And then we describe the last piece over here, which is the methyl group on carbon 7. There you go. Okay, the more practice you get with these, the better. It really helps. All right, the one other part that you need to know about is there will be cyclic alkenes, okay? And it's not going to be too shocking, but there's a little extra twist here. The cyclic compounds means that you got a ring structure with a double bond, and in this case, carbons 1 and 2 are defined as the double bond carbons. So there's going to be 1 and 2, or 1 and 2, depending upon what makes the most sense. Well, what makes the most sense then, I'm going to change the colors, is to decide to choose 1 and 2 so that the substituent gets the lowest number. So we would rather have the methyl group on carbon 1 in this example. So if it's a 6 carbon ring with a double bond in it, it would be cyclohexene this time. And we don't have to specify where the double bond is, it's just in the ring, but we do have to specify the methyl group. And so it's going to be 1-methyl cyclohexene. That could all be joined. I didn't write them close enough together. You could have the methyl somewhere besides the double bond, and then you'd have to count around the ring to give it a lowest number. The structure on the right is another one of these fun things. Sometimes it helps if you draw them out, because you don't always like these ball and stick diagrams. I get that. And it looks to me like you have a methyl on that carbon and a methyl on that carbon. And so the last name, reflects this pentagon with a double bond in it. And so it would be the longest carbon chain, cyclopentene. And now we'll have to describe where the substituents are. 2 methyl groups, but carbons 1 and 2 are, by definition, the double bond carbons. So we want the substituents to end up with the lowest number. If we put, there's 2 choices. I'm going to change colors. It's more interesting. Oops, I didn't change it. Get back here. There we go. If we put 1 here and 2 here, 3, 4, 5, that's probably not the lowest number, right? So let's do the other choice. Or can I just erase that? Does it work? Nope, I won't. I'll just change colors. Okay. So we'll do a different color, and we'll do 1, 2, and 3. So it's preferred. So we're going to have 3 methyl, oh, but there's two of them, dimethyl, and each substituent gets a number as usual. So 3,3-dimethyl cyclopentene. All right, that'd be enough examples for now. A lot of practice is available on your homework. Please ask more questions as needed. Good luck on your homework. See you in class. I hope you find this helpful.